I'm Mrs. Cynthiya, Assistant Professor of Department of Computer Applications in Bishop Weaver College. So today we are going to discuss about function, structure and union in C programming language. So here is the outline: functions and its definitions, its types, call by value and references, nested functions, recursion, and then we'll be moving on to structure and union. And these are the course outline today. First, we are going. So now we'll be seeing about functions in introduction. So function is the basic building block of a program that actually performs a specific task, and it can be executed n number of times. The need for functions are the two reasons. One is code reusability and the other one is abstraction. So code reusability is once a function is defined, it can be used multiple times when needed. And the abstraction example will be using input functions scanf and output functions printf. So in scanf we are going to get the data from the user, and the data has to be read. Okay, so we just invoke scanf for reading the data, and we have not known much about how it has been reading the data, because since it is a predefined function, we are just extracting it, we are just abstracting it, we are just using the scanf. So we don't need to worry about how it functions, how it has to be functioned. So that's why abstraction is one of the concept where function invokes it. So like said in the point, certain functions in C can be used by the user even without knowing its actual working of it. Example, this scanf and printf statements. And then next one, function syntax. So what is the syntax of this function? So in a function, it has three aspects. So the one is function declaration, the other one is function call, and function definition. So normally to declare and define a function, it has to follow three aspects, and the first aspect is function declaration. So what is function declaration? Functions should be declared globally to tell the compiler about the name, parameters and return type. It is actually we are naming a function which has to be performed, and the syntax of this function declaration is return type, function name and with the argument list. So the return type will hold the data type, what data type we have to include in our function, so that has to be included here. So it may be int, it may be float or double. So those type of return types. And function name, it is what we are going to define for our function. What is the name of the function? And the argument list, whether we need an argument list or we don't need. So it is a normal syntax. Now after declaring the function, it has to be called with the help of this function call statement. So the declared function can be called. Okay, so remember here the function name what we have declared should exactly be same when calling it. And the syntax is function name and argument list. We have declared and we have called. And what function has to, what actually the function has to do will be explained and will be elaborated in the function definition. So here function definition, it contains the actual statement which are to be executed. Okay, so here the function syntax for function declaration and the definition, where the declaration has to be ended with a semicolon, that means the statement has ended. But in function definition, we are not going to end it with a semicolon, rather we are pursuing it further with the function body. So we'll see in detail all these concepts. So first one, function declaration. Function declaration, as we earlier saw about what it is actually the naming a function which has to be declared and function in our program. And here is an example. So let's consider this int sum of int a comma int b. Here int represents the return type, sum represents the function name, and both the elements which are inside this parenthesis or argument or parameter list. And each argument list will have the return type and the name. Okay, so this is the function declaration. Normally in C, we'll usually declare the function before the main function. Okay, so we normally call it int main, and then we'll be declaring it. So um, we should be aware that the function has to be declared before the int main. So after that, its definition can be called then and there, or at the after completing this main function. So remember, so this is how the function declaration will be done. Then the function call. So here we have declared the function name sum of int a comma int b, and the call will be like this. It is mentioned inside the main function sum of 20 comma 10. In the previous slide, we have mentioned int a comma int b. Since both the variables are integer type, so here the values should be declared in the integer type. If we have mentioned like something like 20.5 or 10.5, so that will give you the error. Reason, that function is not declared. Okay, so now this sum is your function name and this is your argument list. Then the function definition will goes like this. So it actually gives you the actual performance of the variables need to be carried out. So example, so int sum int a comma int b. So this is the first line. Okay, so here it is the first line which we have declared earlier with the semicolon symbol. And then in the main function we have called with the help of some variables, some integer variables. And then after this, what actually it has to done. So in sum of int a comma b, so inside this the curly braces starts where this part is considered to be the body part, and this particular part is called as the header part. Okay, so this is the header and this is the body. Okay, this is the header and this is the body. So here we are returning. Here in the function definition, here the int specifies the return type, sum is the function name, and this is the argument list. And this particular part is called as header and this particular part is called as body. So the body part will actually specifies what task to be performed under this function. And remember, in the function definition, we should avoid the semicolon at the end of the function name. The reason is the semicolon specifies as the statement has ended. So when the statement is not, has some definitions, the semicolon has to be avoided. The next one, the return statement. The another important statement is written in the function. So the return statement is usually tells what type of value should be returned after the function execution. So in the previous example, we have seen int sum. So the function sum should return the integer type of variable, integer value at the end. And then in our example, same int sum of int a comma int b, return a plus b. The keyword return should be included in this way. Okay, and then if let's put some values under a and b. If a is equal to 5 and b is equal to 3, the return statement will return the value as 5 plus 3, it is 8. Okay, it is actually the integer data type. So the integer function will not return any other data type value. Okay, so if the function is of integer type, the value will also be the integer type. So if it is of float, the return value would have been become as 8.0. Okay, And then in case if you don't want to return any kind of statement, any kind of values, we just use the void at the void as the return type before the function name. So here is the example: void hello printf hello c. So when you mention this data type as void, there is no need to specify the return statement here. Okay. In case if you have mentioned int, float, or double, the return type has to be mentioned. Okay, only the void data type will not return anything. Other than this, any other data type will return the values. So the return statement goes like this. Then we are moving on to how the functions have been working in C program. Let's consider. We have seen separately what is how we can declare a function, how we can call a function, and how the definition will goes. So here is an example what actually the function will work. So this is the simple program of sum of two numbers, two integers. So here is the program. It has header stdio.h, which is standard input output header file. Int sum of int a comma int b. So here is the function. So remember this part. Okay. So this is both where we have declared and defined the functions. Okay. So here the declaration and definition are carried out together. Then in the main function, we have int add is equal to sum of 15 comma 20. So here it is a function call. So then after this one, the printf statement has been added and return 0. So listen here. Here main is a function which is an inbuilt function, and the integer int is the return type. So we have to definitely specify return 0. This must be specified in C. So now what is how a user defined function will work in C. So we have declared and defined the sum function, and in the main we are calling the function call. Okay, so now look into here. So this part is the function definition, and this sum is the function call. Okay, once when the compiler encounters this statement, okay, when the compiler encounters this statement, so it has mentioned that it has declared a variable int add is equal to sum of 15 comma 20. So the variable add will hold the value that will be returned from this function sum of 15 comma 20. So here the sum of 15 comma 20, it is the function call. It will call the function which I have already declared and defined. So the control goes into this particular line. Okay, so here int sum of int a comma int b. So here the two arguments are there, and here also the two arguments are there. So here the a will hold the value as 15 and b will hold the value as 20. Okay, so now here in the body of the function, here the value is return a plus b. So what is a here? Here it is 15 and here it is 20. So 15 plus 20, and what is the output? What is the output? The output is 35. So after this one, after the condition gets executed completely, we are returning the value. The value, which value will be returned? Here the value 35 will be returned, and here the value 35 will be written. So the function will returning the value. So now here add will be given the value as 30. Sorry, I've given the value as 35, and then the control goes to the next line. Here the sum is percentage d. So percentage d is the uh, is the is the sorry is the value for getting the integer type of data. Okay, and here the sum is percentage d. Since it is the integer type of value, we are doing this percentage d comma add value will be added here and return 0. Okay, so now the output will be, 35. Next, we are moving on to the topic types of functions. So there are two types of functions. One is library function and the other one is user defined function. So the library function, it is the built-in function where the compiler package will which I've already built, okay, which is already, which has a specific meaning, and it is actually added predefined in the package. So it has an advantage of being used directly without explicit definition. So in library functions, which is built-in functions, we now need to specify the definition for the functions which are already exist. So these are the built-in functions. User defined function, these are the functions whenever a user wants to add his own function definition. So that particular functions are called as the user defined functions. So it is also called as the tailor-made functions. Okay, so here we'll be seeing an example for library function and the user defined function. So user defined function we have already seen with the previous example, which is int sum. So we'll be looking in another example also. Now the library function. So library function which exists already. So here is an example. Okay. So look into this example. Hash can include math.h. And math.h it is the header file for incorporating all the mathematical functions, all the mathematical functionalities. Standard IO input output header, and int main double number. So we are declaring a variable number as double, and the number will be num is equal to 25. Double square root is equal to sqrt of num. So here the sqrt, it is a inbuilt function or a library function which has its definition already in the package math.h. Okay, so what is square root? We need to find the square root for the value 25. So what is the square root of the value 25? It is 5. So this printf statement, we have done this the square root of. So here, look into here, it is percentage dot to lf. It is, we are declared num as the double integer type, so it can hold n number of decimal points. Okay, so we need only 2 decimal points, so we have mentioned it here as dot 2. Okay, so it, which means it will give you the decimal point of 0.2. Okay, 2 decimal places will be given in the output. So LF, it is a long float, so double, which holds a higher memory space than float, so we'll be calling it with the LF. Okay, so here square root of percentage dot to LF, it takes the value 25, and this takes the value, the square root value. So num comma square underscore root. Okay, and the return value will be 0. And now look into the output. So the output of the output is the square root of 25 dot double zero is equal to 5.00. Okay, so now have you understand this one? So here dot 2, it is the decimal places we are requesting the compiler to give it us. Okay, so if we failed to mention this dot 2, it will usually give you 4 to 8 places the decimal point. Okay, and the square root of 25 will be the output as 5.0 and 0. Okay, I hope this will find you better. Then we are moving on to this user defined function. Okay, so here the same example which we have seen earlier. So here sum is the user defined function. We have defined the function, we have declared. So here we have declared, and here we have defined the function. Okay, so here through this function call, we are calling the function here. So the same output, which is the sum is 35. Since it is an integer data type value to be returned, so the output would be 35. Then we are moving on to the next topic, passing parameters to functions. Okay, so in the previous example, we have declared the function with the variables and we have called the function with the numbers. Okay, so passing the parameters to the functions. So here there are two ways to call a function. One is by the value and the other one is by the references. So before getting into this call by value and call by the reference topic, we are going to see about two important parameters. Those are called formal arguments or formal parameters, actual arguments or actual parameters. So formal argument, it is where we declare a function. We need to specify what kind of parameters it has to accept. The function has to accept what kind of parameters to the function. So in our example, int sum of int a comma int b, which means the sum function is going to accept the parameters int a, integer type of variables a and b. And the actual arguments is where sum of 15 comma 20, it is that the actual arguments, the values have to be passed through that uh, argument list, where it takes the where the variables will take the value and sort it out and will give you the return the values. Okay, and now here the same example. So here int a and int b, these are called as the formal argument, which defines what type of variables, what type of values to be accepted by a function. Then in the actual argument, it is the value which has to be written. Okay, the values in this number actual arguments, this has to be sent to the variable which are already declared in the function definition. So there the a will take the value as 15 and b will take the value as 20, and it will return both the values added and it will return the value as 35. Okay, so this is the actual argument. It is actually where the testing occurs, and formal, it is actually the prototype. We can call it in that way. Then first one, which is called by value. So we are going to call the value. Okay, so this method actually copies values from actual parameters into formal function parameters. Okay, whatever we are mentioning in the function call, the actual parameters, it will be copied to the formal function. Okay, and the function, the changes which have already occurred in the function will not reflect it in the main. Okay, so it will not reflect in the main function. So we'll see it by an example. So look into here. Here is an example, simple example of swapping. Okay, so void swap. Here we are going to swap the values, integer values, variable 1 and variable 2. The values will be swapped here by introducing um, a temporary variable, and then in the main function the variables are added here. Int variable 1 is equal to 2, 3 variable 2 is equal to 2. So printf, we are printing the statement before swap value of variable 1 and variable 2 percentage d. So before swapping the values 3 and 2, we are printing the statement here. What is variable 1 is holding and what is variable 2 is holding. So this is the statement printf before swapping the value, where 1 will hold the value 3, where 2 will hold the value 2. So here comes the function swap. Okay, so when the compiler encounters the statement, the control will move to this function void swap. So here the variable, what is var here? Here the var will hold 3 and var2 will hold the value 2. So here 3 comma 2 will be taken into here. So here in this process, temporary will hold the value as 3, variable 1 will hold the value as 2, and variable 2 will hold the value 3 here. So here the swapping occurs. So after this, look, after this, the value has to be changed after the swapping. Okay, so but the call by value will always will not um sorry, the changes which have occurred inside this function will not affected here. So now look into this output. The before and after swapping, the values remain unchanged. Okay, so this is how. So the working procedure of call by value will be working. Then we will see about what is call by references. So here the actual parameter, the caller's actual parameters and the function's actual parameters refer to the same location, and whatever changes you're making in the function, will be reflected in the caller's function. So here is an example. Same example. So call by references means we are referring to the address space of the variables where the values get stored. Okay, so here references refers to the address spaces. So here look into this declaration void swap of int star var 1. So the star specifies the pointer variable. Okay, whenever you specify a star before a variable, it is a pointer variable. So this topic will be discussed in coming classes. So now pointer variable, whenever a variable is declared with the star operator, that is an asterisk symbol, it is a pointer variable. So here we are swapping the variables, and the main function, what we are going to do here, we are going to specify this with the ampersand symbol, which means the address symbol. Okay, so the address symbol. So now the output will be, before swap value of var1 and var2 is 3, 2, and after swapping the value will be changed to 2, 3. Okay, so now here, so address of variable 1, address of variable 2. So what it will hold, both the actual parameters will refer to the same address location. So whatever changes you are doing there, in that location, whatever the variables, whatever the values are there, that will be affected in both the functions and in the main functions also. So this is called by reference. Then we are moving on to the function returning more values. So if you want to return more number of values from a single function, we need to specify it with the asterisk symbol. So it is a function, it has to return two values, which is quotient value and the remainder value. So for that purpose, we are including the variable with the asterisk symbol, that is a pointer variable. Whenever you specify a pointer variable, you are referring it with its address. Okay, so with this output, look into here the working principle of this one. Int a is equal to 76 and b is equal to 10. So these values will be taken into here in this function called div of a will hold the value 76 and b will hold the value 10, and this address space of q comma address space of r. So this will be moved to this place. Okay, the control goes into this place. So here, so quotient is equal to a by b. So which means this value has to be stored on this quotient address. Okay, so a comma a divided by b. So what is 76 divided by 10? What is the quotient value? The quotient value will be 7. And what is the remainder value? So here we are taking the modulus, so the remainder would be 6. So after this one, the print statement will print quotient is 7 and the remainder is 6. So this is the way how we can return more number of values from a single function declaration. Then we are moving on to the topic function as an argument. So here we have seen till now we have seen a simple function, how we can call it, and here is an example that we can pass a function as an argument also. Okay, you can make a function as an argument list to another function. Okay, and here function as an argument. So look into this example. Hash can include same header file. Here there is one function int add of int a comma b. Here we are adding it, and then int subtraction of a comma b, we are subtracting it. So the two functions add and subtract. And then we are having the third function, which is int calculate of pointer function, which is operation of int comma int a comma int b, which is going to return operation of a comma b. So here it is the way to declare a function as an argument. So how does it work? So int main, here we are calling the values x is equal to 100, y is equal to 200. Int sum is equal to calculate of add comma x comma y. Okay, so for that purpose, look into here, we are going to add the values x and y. For this, we are calling a function called calculate, which is holding another function called add. So now the control gets into here. Okay, so here what it will do, int calculate of, what is the function it is calling? It is calling the function add. Am I right? It is add. Add of, what are the variables it is going to carry out? Okay, so it is going to call a function int functions. Okay, it is going to call a function add. Okay, and then what are the variables it is holding? X. So int a will have the x and int b will have the y. So now what it will be doing in the return statement, a return operation of a comma b. So what is the operation it is taking here? Here it is taking add of a comma b. What is x and y here? Here it is going to take the value x comma y. Yes. So this return function is going to return the value which is returning from this function. So again the control will goes to this function here. So now here, what is x and y here? Okay, so x is holding 100 and y is holding 200. So here in this function add of int a will hold the value 100 and int b will hold the value 200. So now it will be returning a plus b. It will return the value. So which is, so here the value will be 300. It is returning the value 300. So the control go backs here. Okay, it will come back to this calculate function, and here it returns the value again to this statement. Understand? So like this way, int diff of calculate of subtract x comma y will be done. So after this, what is the sum is holding? Now the sum is holding the value 300 and this will be printed in the printf statement. So this is how you can pass a function as an argument into another function. So this is the output, sum 300, difference minus 100. Next one, the nested functions. So we are going to add a function inside a function. So previously we have seen we are going to add a function as an argument list, but here we are going to invoke a function inside a function. Okay, so the main function, basic example, we are having the int main. Main is actually the function. So inside this main function, we are calling several other functions like scanf and printf. So this is an example for nested functions. So we have declared the main function and have called the other predefined and user defined functions inside it, like printf, scanf, getc, putc, etc. So that the main function can be known as a nested function. So here we can, this nested function can be assumed to be a block scope or function scope. Now we'll be seeing an example for this. So here int num cube of int num. Inside this I am calling in another function which is cal cube. So this is the function inside the function num cube. So here it is going to return the cubic value. Return cal of cube. Okay, so it is returning the value and then it is returning the function's value here. So int main. So here int x comma answer printf enter a number. So here the user, we are prompting the user to give the input. So enter a number, scanf percentage %d and recent symbol x. Then answer. So here the function will be going to this function. Okay, so the cube of value whichever we are entered will return the output here. So look into this example, output of this example, enter a number which is 5, the cube of 5 is 125. So here the value 5, okay. So here, ma'am, we have mentioned a simple variable here, but we have added here as a ampersand symbol, which means the scanf statement will always, whenever you're getting a data, you have to specify it with this ampersand symbol. Okay, because the value whichever you are entering to the value x will be taken into its address spaces. So the 5 will be taken into x. So num cube. So x will hold the value 5. So here the num value will become 5. So inside this we are returning the value num into num star, num star, num star. So 3 times. So it is 5 into 5 which is 125. It is returning the value as 125. So now after this one, what it is getting here, return cal underscore cube. Okay, so this function, this statement, okay, so once the 5 is here, it will be returning this statement. Okay, again the control goes here, then only the value will be returned here, and then you will get the output as 125. So this is nested functions in C. Then we are moving on to the recursion. So recursion is one of the important topic under functions. So recursion is the process in C programming language which allows to repeat a certain section of code in the program. Okay, so this allows the user to call the function. Okay, we are going to call the function by itself. Okay, so this is called as the recursive call. So example, so the recursion in a C program continues further until and unless it meets some condition to ultimately prevent it. Okay, so the end condition has to be given in the recursive function, else your condition will not, your control will not get stopped. So recursion. So here is an example for recursion. So without recursion, what we are going to do is we will be involving several other control statements to perform it. So in recursion, this is an example for this. We normally have the factorial. What is the factorial of 5? Okay, so whenever we'll call it about, talk about factorial, we'll decrease the number. Okay, so for 5, the factorial will be calculated as 5 into 4 into 2, 3 into 2 into 1. Okay, okay, so this is your factorial value. So what is the value? 5 4 so 20, 20 into 6, it is 120. Okay, so factorial of 5 is 120. So we need to perform it. So for this, this int factorial of int It is a recursive function. Why it is a recursive function? So look into here, we are calling the function same. Okay, inside the function factorial, we are calling it the same function again by decrementing its I value. Okay, so our motto is to call only one time in the main function. Int f is equal to factorial of a, the value is 5, and here the control moves to this place, and now the value of I will be taken into 5. So it will check for the condition. If the value is less than 1 or equal to 0, it would return 1. Else, if it is not, it has to return I into factorial of I minus 1. So now this particular stage, on the first iteration, on the first function call, the function will be returned as 5 into factorial of what is I minus 1? It is 4. Okay, so this will be written. Again, the condition goes there. Okay, now what it will be done? What it will be done? So again, this repeatedly, recursively, it is calling its own function again and again. So that's why in recursion will give you a proper guidance to enhance your coding. Okay, so now the output would be 5. The value of factorial of 5 is, it is 120. Okay, so again on the second call, okay, on the second call here, it will be again taken back into this one. So now what will be the output here? And the second call 5 star, this one 4. This one is again calling in another factorial function, which is fact of I minus 1, which is 3. Okay, so this is how the factorial works recursively. So with this, I hope the function topic gets completed. Now we are moving on to the next topic, which is structure and union. So structure and union. What is structure? Structure in C is a derived or user-defined data type. It must use a keyword structure. So we usually define different types of data type into a single format, that is called as the structure. So array is where we declare a same type of same integer type data to be clubbed, that is called as the array. Here the structure is what we are trying to accommodate different types of data structure into one particular type. Okay, so example we have included here is book. Okay, so a book will hold the title, who's the author, and date of publications, number of pages. So here the author and title will be the string data type. Price will be in the double, okay, in the double data type, and the number of pages will be in the integer type. Okay, so this is a simple example for structure. Instead of using 4 different variables, we are using the structure in a single structure. What are the features of structure? So it reduces their complexity, it stores heterogeneous collection of data items. Remember, array will hold the homogeneous collection of data items, structure will hold the heterogeneous collection of data items. So it increases your productivity. In a single structure, you can incorporate all types of data. So example, for an employee detail in a company, it has to be his ID, so which is a number, name, it will be in the string format, and its date of birth, date of joining, those will be under the date type, salary in the float or double type, work designation will be in the string type. So these are multiple different types of data types will be there. So this will be accommodated in a single structure where it will increase your productivity by reducing multiple usages of different data types in different genres. And it is maintainability of code, it enhances the code readability, and it enhances the mathematical operations efficiency. And how you can declare a structure? So you must use the keyword struct, and this is the syntax. So syntax will hold This is the structure, it is the keyword. Structure tag, you have to specify what structure name. And these are some of the member definitions. What type of structures, what type of members you are going to add. Okay, and one or more structure variables. You can add more structure variables. So structure variables is where you call the structure back. So example struct book, it is holding the title as character, author as character, and this 50 specifies the array. We are declaring this title as array, and double price int pages. In book 1, it is the variable through which we are going to call the structure. So structure variable declaration will be this way, struct of book 1. Next one, initialization, how you can initialize. So the initialization of a struct variable is done by placing the value of each element inside curly braces. The following statement demonstrates the initialization of structure. So struct book 1 is equal to learn C, Dennis Ritchie, 6675.50325. So here this takes place the title, this value takes the title, this takes the value author, and this takes the value price, and this takes the value number of pages. So this is how the values of the variables which we have declared in the structure will be initialized. Okay, so to access all these members, we will be including the operator, dot operator, along with the structure variable. There is an example here. So look into this example. Here we have declared the struct book, title, author, double price, int pages. Int main. So here the main, which where we have declared the variable struct book 1. Okay, so now we are going to print f. Okay, so we are going to print the statement. We have already declared what are the elements to be added to that structure variables. Okay, so now how, in what way you are getting this value? Book 1 dot title. So book 1 is your structure variable which has to be invoked, dot title. Okay, so what is the title? It is learn C. So remember, in whatever format, in whatever numberings you have given this one, try to add in that way. So book 1 dot title. So normally at the first index which is a 0, at the 0 index place, first one will always consider to be the title because we have structured in that way. So book 1 dot title will be, the output will be learn C. Then book 1 dot author, the value will be Dennis Ritchie. Book 1 dot price, the value will be 675.50. Book 1 dot pages will be the page numbers 325. Printf size of book struct percentage is size of struct book. Okay, so we are going to add the size of, what is the size of this one? Okay, so with the help of the size of function, which is a predefined function or library functions available. So now the output would be this one. Okay, so title learn C, author Dennis Ritchie, price 675.500. So remember here we have mentioned here long F, a long float LF. So here long float, look into here how many digits it has been giving. It has been giving us 6 decimal places. Okay. So if you don't need this much of decimal places, you can mention here 0.2. You just need only 2 decimal places. You can specify here. Okay, if you don't specify, it would usually represent with the 6 decimal places. And in how many pages? It has 325 pages. And what is the size of book stock? It is about 40. The next one, structures within structure. So likewise, wherever we have already seen function within a function, likewise structure can also be included inside the structure. So it allows, C programming allows us to create nested structures, that is one structure within another structure. So it is for us to create complex data types for storing various elements. Okay, the nesting process can continue as long as the user wants. So here is an example again. So what we have done. So previously we have added we have added the price into a single structure. Here we have added struct book and struct price. Under the struct price, we are calling the structure book inside the struct price. So we are nesting the struct book inside the structure price. Okay. So struct price B1. Whenever you are calling this one. Okay. So now the structure variable price B1, whenever you are giving the structure variable and giving all these data, so the control will go back to this place. So here for the price, the value will be taken here, but the rest of the variables, rest of the fields, the values will be getting back to this structure book. Okay, so this is structure within structure. So this is how the structure within structure works. The first book details are as follows. So here the printer, name, author, pages. Remember the structure variable should be called for the structure where it is nesting in another structure. Okay, so in case if you call this struct book B1, it will have only the name, author and pages, and it will not take the price value. If you want to take the price value also, you can specify the variable, structure variable to this structure price. So by this one, B1 dot B dot name, B1 dot B dot author, B1 dot B dot pages. Okay, so now the output will be this way. Okay, so B1 it is the structure variable and B it is the variable for structure B, structure book, and B is for the variable for structure uh, price. Okay, so where does this B comes from? So we are calling this structure book by a structure variable B. Okay, so for this B, this has to be added here. Okay, for price, we no need to add this any other further variables. We'll be adding B1 dot price 1. So that will be fine for your output. And then next one, type def. So what is type def? Okay, so in C programming language, it provides a keyword called type def. You can alternate a text for already existing data type. Okay, so if a data type is too long to understand or making to remember it, you can change the name. Okay, so the type def keyword at C is very useful in assigning a convenient alias to a built-in data type as well as any derived data type such as a struct, a union, or a pointer. In general, the keyword will be this way: type def, existing type and new type. You will have to specify first what already existing type and then the new type. So here the example type def, and this one short unsigned, it is the existing type. Okay, it is the existing type, and short unsigned int, it is the existing type, and u short is the new type which you want to define. Okay, it may be anything, whatever name you are comfortable with it, you can give that name. Okay, so now u short denotes short unsigned int. So once you have typed this particular statement in your program, uh, you can use this u short in the place short unsigned int. Okay, so if x has to be declared in short unsigned int, so in rather specifying the entire long name, you can make an alternate name using this keyword type def u short x. Next one, enumerated data types. So enumeration is an enumerated data type that consists of a group of integral constants. It is useful when you want to assign user-defined names to integral constants. The enum keyword is used to define enums. To declare and define an enumeration data type, you have to use enum keyword followed by the enum name and to assign the values inside the curly braces. Okay, and this is the syntax there. And there is an example for this. This is a simple example. So we are specifying this weekdays. Okay, weekday is the enum name. Enum is the data type. So inside this curly braces, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So we are going to print the statement. So what it will do, this Sunday will normally hold the value as 0. Monday will hold the value as 1. Tuesday as 2. Wednesday as 3. Thursday as 4. Friday as 5. And Saturday as 6. Okay, so now printf, the output would be Monday is equal to 1, Thursday will be 4, and Sunday will be 0. So you are giving the user defined names to the integral constants. So the here in this enum type, for weekdays, Sunday is the user defined name which is holding the integral constant, which is 0. Whatever variables you're specifying inside the curly brace, the first variable will always hold the value as 0. So this is the user defined names given to the integral constants. And then last topic is union. Union, it is a special data type. More or less union and structure are similar. Only the difference is they carry the keyword struct and carry the keyword union. Here in the union, it actually hold only one value at a time. In a structure, it will not hold a single value. It will hold the entire data members. In union, it will hold only one member that can contain a value at any given time. Unions provide an efficient way of using the same memory location for multiple purposes. So it provides you the shared memory spaces. Okay, and the keyword union is used, and this is the syntax: union, union tag, and the member definition, and union variable. And to access any member of a union, you need to specify with the dot operator as in structure. And assignment operator is for assigning the values to the members of union. We can initialize using the assignment operator. There is an example for union. So here the data is your union type. So here it holds int I, float f, character, string 20, and union data and data. So this data is the union variable for declare. This is the variable used for union declaration. Data dot I is equal to 10, which means this particular data variable, this particular union variable dot I, which means this variable is accessing this member in the union and it is holding the value 10. So this is initialization and declaring the values to the variables in the union. So we are going to copy string copy function data dot string C programming. Okay, so here we are going to copy this C programming string to this string variable, and now the output would be, this is the output. So this is an union, and the main difference between structure and union is union uses the shared memory space for single member, and rather your structure will not be using that. I hope this lecture finds you useful, and thank you for your time.